Hi everybody, this class is about machine learning with graph data. My name is Hogan Park. I will be your instructor of this class. This is the first class and I will briefly introduce the topic of this class and the logistics and textbook and etc. And this is the course overview once again. And so we need to talk about the machine learning and deep learning first. As you know, machine learning is a type of artificial intelligence that allows software application. So we use the technique to predict some outcomes based on the previous observations. So what is the example of the observation? Maybe I can give you the example using the stock market data. So to maximize your benefit, so we try to use the previous observations. So observations could be the previous stock prices and news articles about that. So we can use the information about the economic analysis, economics. So your market status and the customers' information and how people feel about the product of a company or the trend of the new market. For example, some electric vehicles, or what else? Some new game technology in AR and VR. That information could be used for predicting outcomes. So that is the example. And what about deep learning? So deep learning is a part of machine learning methods, and it is most of the deep learning is based on the multi-layered perceptions and their variants. So you're already familiar with the CNNs and LSTMs and GANs, right? So it has been used for the image data and speech data and categorical data, right? So the deep learning, the advance of the deep learning leads the major advances in the recent technologies, right? So self-driving cars and machine translations. And in this lecture, so we try to focus on the advances of the deep learning, specifically for the graph or networks data. So why graph data? So why it is important? So graph is a natural representation for describing and modeling complex systems. So this is the example. This single dot represents person, movie, and device and protein, for example. In the traditional machine learning problem, they try to understand these person and movie and device and protein individually without considering their dependencies and their relationships. So for example, we try to predict the gender of the person by looking at their features, such as their communication patterns, the frequency of the some visiting patterns to some restaurants, or how much time they stay at school, something like that. And we try to guess the gender of the person or the genre of the movie or the type of the device by looking at their histories. Or we try to maximize the probability of the person's observation. So we can model the people's behavior by just maximizing the probability of the all people. So we use this probability in the generative model, for example. Anyway, within the traditional model, we don't assume they have some dependency. What about we consider there exist edges between the person or movies or devices and proteins? The example could be the communication. So whether they are communicated or not in the person, or in the case of the movie, we can make an edge between the movies by considering some actors are co-acted between the two movies or not. In the case of the device, we see the devices, the interacted or not, protein could be similar. So by looking at this, we can solve the same problem, right? So not just looking at the person's their attribute or features. We also looking at the person's friends, right? We see how often they communicate with some other males, other person, and we can see their features, right? And we can the more easily guess the gender of the person by looking at the person's friends, right? So we try to leverage the additional information in addition to the each person's attribute. So this is the difference between the traditional machine learning and the relational machine learning. The representation of graph enables this relational machine learning. So obviously we can get a better accuracy compared to this traditional machine learning. And when we use the relational machine learning, so we expect better accuracy, right? So we have the graph data in our lives, right? Social networks and economic networks and biological networks, information networks and internet and neurons. We have so many relational data. So, and we also need to think about why it became more popular than before. So people all know the graph representation is better representation, but we didn't have enough data before, and by having more data available, and we can expect better accuracy and better modeling performance. And at the same time, we also have many algorithmic breakthroughs, particularly from the deep learning. So it has big impact on the social networking, the modeling social networking, and the learning social media to use for the other some marketing or stock price prediction tasks. And in drug design is also one of the important applications. In common sense reasoning in IoT, the common sense reasoning is to understand the situation to model the communication and interaction. The IoT is just like we can guess the situation of the people. When you come into the house, we need to understand their intention. We can turn on the air conditioning system or turn on some light, or we can control some devices at home, and we can get we can expect some big impact. So we have several fundamental tasks in the machine learning with the graph data. So one of them is a node classification. So we can, for example, we can predict a type of the given node by looking at the connected nodes. We can also predict a link. So this is the second example. So it is to predict whether two nodes are linked or not. It could be utilized for in your KakaoTalk, for example. So in your Facebook Messenger, in KakaoTalk Messenger, it is important to predict your next communication. And so when the prediction is available, and we can give some more intelligent support, such as we can prepare some the file attachment in advance, or we can adjust the order of your friends, something like that. I'm not sure. So you can think about some intelligent user interface, right? Or we can give better advertisement. You can recommend some product. Or for the third example, to community detection, so we can identify densely linked clusters of the nodes. So particularly it is useful when the labels are not available, right? The getting labels is always very expensive, right? We need to understand the node. So think about in your Facebook data, to get the label, such as the gender or your religious status, and we need to ask them, right? Due to the privacy issue, they don't want to reveal their information. So to get the label, we need to pay them, right? Pay the money to them. So that's why it is difficult to get the labels. So for that reason, we use some community detection sometimes, and we can understand some overall global distribution about the data, and we can determine the important strategy in your company, something like that. What about the fourth example, the network similarity? So we can decide how similar the two networks are. So you have one protein and another protein example. So when you understand the one protein examples, which is potentially related to the cancer, and then when a known network protein interaction is given, so you can guess that, oh, this interaction is also related to the cancer symptom, something like that, right? So a very useful example. So this is example, right? So some supporting figure for understanding the node classification. So color represent the known label, such as the gender, and by leveraging the known genders, and we try to guess the class label, the labels of the gray nodes, right? I put a question mark here. We try to guess the labels of the gray node, and by looking at their own attributes in their friends' information, we can guess their genders as well, right? And ring prediction, we try to predict their future interaction, right? So I already explained in the previous slide. So this is related to the content recommendation, right? Think about your coupon purchasement. So by looking at your the previous order, or in your the how to say in English, in your the grocery bag, in the online grocery bag, right? In Korean, 장바구니, right? In the coupon, you put something the 장바구니, right? The grocery bag, and you see based on your behavior, the coupon recommend potentially related articles, because some people already purchased the same product. At the same time, they also bought another items, and we can guess that their items are also related to the future behavior, right? So that is deeply related to the link prediction, right? So we assume that this link is the buying action. So we try to guess your future buying action. So we can understood that problem as link prediction. So why it is hard? The modern deep learning toolbox such as the CNN and the RNN, and they worked pretty well in the image processing and text analysis, but they assume that the fixed size or fixed locality. For example, image, in this pixel, we have the 3 digit in this example, but we guess that it clearly has left and right and up and down information. So by looking at their nearby pixels, we can guess the boundary of the digit, and this is utilized for the predicting the labeled this input image. What about the graph data? We don't have left and right and up and down, so impossible to apply the CNN techniques to the graph data. This limitation apply to the RNN as well. So we don't have sequence, so difficult to apply that technique to the graph data as well. So in this class, so we deal with how to overcome that difficulty. So one of the solution is to use the graph representation learning. So this is a quickly grown subfield of machine learning. So we will study about the recent advances about the graph representation learning, and we will give you introduction to the graph representation learning, some matrix factorization based methods, and random walk based methods in graph neural networks. So we will study both the theoretical motivation and practical applications of these methods. So here are some tentative topics. So we are gonna start with the graph statistics and basics and link analysis, node embeddings, label propagations, and graph neural networks and knowledge graphs and generative models for graph data. And as you know, we have the class on Thursday, but due to the pandemic, we don't have the offline class this semester. So recorded lectures will be provided, but don't worry about it. So we have live Q&A session. Hooray! And every 2 or 3 weeks, so we have live lecture. Live Q&A. So during the session, we just get question and answer about your homework and about your lecture. So recorded lecture will be provided before the Q&A session, and you need to ask questions if you have any. Otherwise, we just quickly close the WebEx chat and WebEx lecture and they enjoy the weekend. So we see how it goes. And send me emails using this email address. And we have online office hours, but by appointment. and send me email in advance. And we don't have TA and office hour yet. Who knows? I don't know. And webpage. So we will use iCampus. So the lecture video will be uploaded to the iCampus. And we have prerequisites. So you have to you had to take at least one programming class and one probability or one linear algebra classes. So this is the mandatory option, mandatory thing. And here are 4 textbooks. So, but you don't need to buy. Some of them are available online. So if you need, I will give you the link about the chapters about the textbooks here. So if you need, but you don't need to buy. So every lecture content will be available to you. So if you understand the lecture slides, it'll be fine. If we need some reading assignment or reading material, I will give you the link. So Workload, you have homeworks and programming projects, and I will give you more details whenever we have the homeworks and projects. And rate policy, so 50% off per 1 day late, maximum of 5 days, otherwise you have some 0 point. And you have 4 extension days without the penalty, which means you can submit your homework at most 4 days and you will get 0 point penalty. But it cannot be used after the final day of the class. And regarding the exams, so we don't have exam in this class. So grading, so all in participation, 10%, 50% for the homework, and 40% for project. It is simple, right? And project, and you can choose any topics about the graph ML, and we will have the project proposal presentation near the midterm period. We have the final report and final project presentation near the end of this semester. So I encourage you to collaborate on this project. And so we expect 4-page write-up about the project, and depending on the number of people in your project group, and the option will increase. The rank of the mandatory page will increase. All right. Yeah, I will give you more details about the project later. About the communication, we can use the bulletin board in the iCampus, the Q&A board, and email communications. So for that, please specify the objective of your questions. So here's a good title. So how to choose hyperparameters in load embedding models. This is a very specific and very good, right? What is a bad title? Questions. So questions about the lecture. So very difficult to disambiguate because there's no option to see the contents in advance in the iCampus, the Q&A board. So difficult to notice that this is a new question or old question, right? It's good to recall, it's good to come back to the question. So when you specify your question title, and it helps for everybody. But we strongly recommend asking questions during our WebEx Lab lecture, right? It is more convenient to clarify the question right? I can give you more examples and details about the question, and all people participate, so it is better, right? And we have many international friends in this class. I'm not sure, at some point we don't have, but usually we have many international friends. So please use English for communication in all assignments. If you use Korean, you cannot get all the points. You have 0 points. All the homework, all the questions, you have to use English. No exception. So we have the honor code as well. We encourage the collaboration, but please avoid, don't copy other people's solution in online code, right? If the plagiarism is detected, and your final grade will be immediately F. So if you copy codes and sentences, even one sentence, which is available online or in solutions, so you will have 0 points and get F grade immediately. So with some exceptions, right? So some very obvious API calls, such as NumPy and PyTorch library, right? Like a reshape or some defining a new layer, new fully connected layer in PyTorch. So typical to avoid, right? But you see that, right? This is obvious. So I don't count for this, for the copy. But when you copy the order of the API calls, or some how to deal with the variables, something like that, right? When this is obvious, and I don't mind. So some lectures are from the lecture slides. The contents could be from the textbook, and we'll give some when you have some related content, and I might use the Stanford CS224W slides. All right, so this is the end of this first class, and when you have any question, let me know.